In this video, we are going to talk about concurrency in Java. Concurrency means doing things simultaneously and at the same time. For example, when you are working with your phone, you may read a book. At the same time, maybe you are listening to a music and also maybe downloading some file. But how can you do all these things at the same time? Well, with the help of concurrency. Every Java application starts with a thread called the main thread. Thread basically is a unit of execution in your device's processor. We will talk more about threads in a few minutes, but for now you just need to know that every Java application starts with a thread called the main thread, or if it's the Android system that you are running your application, it also can be called the UI thread, the user interface thread. And from that thread you can create other threads in your processor. And the way you create other threads is like this. You type thread with a capital T, let's call it thread, is equal to new thread, like any other Java class. Inside the parentheses of this thread, I need to pass an interface called runnable. I can say new runnable. The first one is our needed interface. When I pass that runnable, it will create this run method for me. Let's finish our sentence in here with a semicolon. This run method is the method that will be executed inside another thread. For example, I can print something in here. Let's say hello from another thread. After the creating of this thread, I just need to call the start method. I can say thread.start. Let's run our application and see if we can see that message. You can see that our simple message has been printed. But how can we know the difference between the main thread and this new thread that we just created? Let's create a for loop in here inside this run method. For int I is equal to 0, our initial point, I less than, let's say 10, and I plus plus. For every time that we loop, let's just print some message. Let's say printing I. After this print statement in here, I'm going to sleep my thread or maybe freeze my thread. I can do so by typing thread with a capital T and dot sleep. Inside the parentheses, I need to pass an interval, for example, let's say 1000 milliseconds. This way we are freezing the current thread that we are in, for example, this new thread that we just created. After every time of looping, we are going to wait 1 second. And after that, loop once again. But notice that this 1000 millisecond is not accurate and you can't depend on that. But right now I'm getting some warning, and the warning says unhandled exception, or to be precise, interrupted exception. You can overcome this problem by clicking on this red light bulb and surround your thread.sleep with a try catch. We will talk about this try catch block and also these interrupted exceptions that we are catching. But for now, let's just run our application and see what this little application does. You can see that every second one integer is printing in the console. And let's change this number to 5 so that we could waste a little less time. I'm saying that this run method is executing inside another thread, but if I come down in here after the starting of that thread and create the same for loop, for example, let's copy all of that from up here and write it down once again. Notice that I'm sleeping the main thread for 1 second as well. If I run my application, you can see that both of those for loops are happening at the same time. This is the concurrent programming, doing things at the same time. And if you want to see the difference, you can simply add some message in here, let's say from main thread, and up in here from another thread. These are happening at the same time. These are happening at the same time. There are a lot of other concepts related to concurrent programming, like thread pools, maybe handlers, and all sort of stuff in Java, but I'm not going to go into details of those concepts because in Android we have a lot of options that can handle working with threads a lot easier. And if you remember from the content video, I intend to talk about those concepts in an entire session called networking in Android. For example, we will talk about things like async task, maybe job scheduler, work manager, and all that stuff. For that reason, I'm not going to spend a lot of time in here. Just let's talk about this try catch block. When you are working with your application, a lot of things can happen. For example, you may receive a phone call. You expect your phone to go on hold until the phone call is done. Or in another word, you may want to handle the interruption that can happen to your application. For that matter, we can use this try catch block. We are trying something. For example, in this case, we are trying to sleep our thread for 1 second, and we are catching the exceptions that could occur. For example, in this case, we are catching the interrupted exceptions. And inside the catch block, we can, let's say, print a message or maybe show some message to the user so that our application don't have a crash or an ANR dialog, or some might call it application not responding dialog. We don't want that because it can cause bad user experience. For that reason, we are going to catch all the different exceptions that could occur when we are working with our application. Interrupted exceptions is one type of exceptions in Java. There are a lot more of them. For example, if you remember from the beginning of this session, if we wanted to divide some number by 0, for example, let's say 2 divided by 0, we would get a crash. Let's run our application. You can see that I'm getting an exception. In a real world application, this means you have a crash in your application. You don't want this. The thing that you can do in here is creating a try catch block. You can do that by saying try something and catch something else. If you don't know the type of exception that you are getting, you can type the general name exception. Let's name it E. And in here, let's just print something. Let's say not dividable. And inside the try, I can say print 2 divided by 0. This time, if I try running my application, you can see that the not dividable message has been printed. It's not perfect, but it's better than getting a crash. The type of exception that we are getting in here is called the arithmetic exception. And if I change this exception to arithmetic exception, it will work fine. Let's just comment this line of code as well because we don't want to be distracted by them. If I run my application, I can see that it's working fine as well. Arithmetic exception and interrupted exception are two types of exceptions. There are a lot more of them. For example, IO exception, it stands for input-output exception, maybe null pointer exception, and a lot more of them. We will talk about them when we use them, but for now, we know the process of catching some exception with the use of this try-catch block. In fact, it's worth mentioning that if you are working for a high-level company like NASA, your code shouldn't have these try-catch blocks because they expect your application to be as precise as it could be. For example, your application shouldn't possibly divide some number by 0. For that reason, they want you to not to have try-catch blocks in your application. Our Java session is done and we are good to have a challenge to wrap this session up. But before that, I just like to talk about another concept called null values. Let's delete all of these before talking about that. We have talked about the different data types, for example, primitive data types in previous videos. For example, if we wanted to save a number, we could say int a is equal to 5. Or for example, for a string, we could say a string name is equal to some name. But instead of passing a text, for example, for this name, I can say something like null. This null means nothing. In some languages like Python, null itself is a data type, but in Java, it just means nothing. When you don't know what the value of some data type is, you can use this null. You can also check for null values of different data types. For example, you can check if your name is null or not. If name is equal to null. You can check for null values of strings. And also, you need to be careful about the null values. For example, if I try to do some operation on this name, for example, let's say name dot equals some text. If I try to do this, if I run my application, I should get some crashes. And as you can see in here, the exception is null pointer exception. It means that the variable that you are trying to do some operation on it is null. Once again, you can overcome this problem by creating a try catch block like this. This time I can say null pointer exception, catch those. Let's just print it's null. Now if I try running my application, it's printing it's null. Okay, that's enough. Let's talk about our challenge. I want you to create an application that will simulate your phone's contacts and messages. First of all, I want you to greet the user with some message, and after that message, show 3 options to the user. 1 for managing the user's contact, 2 for sending a new message to some contact, and 3 for quitting the application. In case the user selects the first option, which is manage contacts, show list of options. To show a list of all contacts, another one for adding a new contact, and also give the user the ability to search for a contact, another one for removing a contact, and the last one for going back. Notice that in here I'm saying add a new contact. I don't expect you to save the contacts inside something like a database because we haven't talked about databases. We will talk about both local databases and also cloud databases in future videos, but for now, you may want to save your contacts inside an array list or maybe a map or whatever collection you may find useful. If the user selects the second option, which is sending message, ask for the contact's name and also the message that he or she tries to send to that specific contact. And of course, for the third option, just quit the application. This is a simple challenge and we are going to make sure that we are at the same page. We are going to work around different concepts like object-oriented programming, collections, simple conditional statements, maybe different loops, and also about different data types. Okay, go solve the challenge and come back when you are done. We are going to solve it together in the next video. See you in the next video.